So today we're going to talk about solving trig equations with b greater than 1. What we mean by that, right, is like this, right? Y equals sine b theta. So if we consider for a second sine of theta equals root 2 over 2. Well, I know what that is, right? If I need to, I can look at all students take calculus or all students take chemistry, depending on how you've heard it or whatever else you've heard. And we know that in the first and second quadrant is where sine is positive. So theta would have to be pi over 4 and 3 pi over 4, right? But now we're going to look at sine of 2 theta equals root 2 over 2. And here, right, this is my b value. And what does the b do? The b controls the period of the function. The period of the function is how long it takes for one revolution of the graph. How long it takes for one revolution of the graph. Not to be confused with the frequency, which tells you how many revolutions happen between 0 and a certain number. And for sine and cosine, that would be 0 and 2 pi. How many revolutions happen between 0 and 2 pi? And what do we mean by a revolution? Well, a revolution for sine looks like this, right? It's the amount of graph between the same two minimums or maximums, right? So minimum to minimum, maximum to maximum, same place to same place, right? So here we have b being 2. So let's take a look at what that means. So if b is 2, we know that the period equals 2 pi over b. So here the period is 2 pi over 2, which is pi. So what this means is that the graph completes one full revolution between 0 and pi. So if we look at that, right? What that means then is that you're going to have 2 full revolutions between 0 and 2 pi. Let's take a look at what I mean by that. If we just look at sine of theta, we actually complete a revolution between 0 and 2 pi. 0 and 2 pi. So look, see how these graphs are different? Here, I do one full revolution between 0 and pi. Here, I only do half a revolution between 0 and pi, which means that I would actually complete 2 revolutions between 0 and 2 pi. So if I do that, this is actually 2 full revolutions between 0 and 2 pi. So we know that this was pi, right? And so that means that if you wanted to take a look at what each of these x values were, you might divide by 2. Divide 2 pi, divide the previous increments by 2. So here, we know that if it completes 2 full revolutions between 0 and 2 pi, let's think about this for a second. With the exception of 1 and -1, we know that the same y values in this graph, sine of 2 theta, happen not twice like sine of theta, right? So here we know we would hit, for example, this might be 1/2, right? So this is 5 pi over 6, 1/2. Right? But here I might hit 1/2, I will hit 1/2 4 times instead of 2 times. Okay? So that is the same, that concept is the same for how many times it will hit root 2 over 2. So actually we will have 4 answers between 0 and 2 pi. So now let's take a look at the algebra. If we go back to y equals sine of 2 theta, and now we're saying root 2 over 2 equals sine of 2 theta, let's let 2 theta equal z. So we know that if that's the case, sine of z equals root 2 over 2. And so we know here that z would be pi over 4 and 3 pi over 4. But remember, z was 2 theta. So 2 theta equals pi over 4 and 3 pi over 4. But we want to isolate theta. We don't want it to be 2 theta. So now what we're saying is, so if we divide both sides by 2, which is really multiplying by 1/2, right? Then we would get theta equals pi over 8 here. And for 2 theta equals 3 pi over 4, when I divide by 2, I would get theta equals 3 pi over 8. So, but remember what I said was that we actually have 4 answers. So the question is, how do I find those 4 answers? Well, if you remember, if we go back to this graph, sine of 2 theta, okay, so let's take a look for where we're going to see these values. So we know that root 2 over 2 happens kind of around here and around here, right? Those are our, this would be our pi over 4 and 3 pi over 4. And then what you notice is that they're over here, right? Now we know that this is pi. So it looks funny because what's happening is that these two values over here look like they're actually going to be not in the first and second quadrant. But that's okay. Because of the way the period works, it's okay. And really, we will consider them in the first and second quadrant. And what do I mean by that? So let's take a look, for example. You can almost think about this like you're going around the unit circle twice. If I have my unit circle, right? We're making a full, remember, a circle, this going around this circle is like making one revolution of your graph. It's kind of like making one revolution of your graph. So you can kind of think about going from here to here, like making one revolution around the unit circle. So what I'm going to do is I'm going to say, okay, pretend I went around the unit circle once. Okay, so we know that this would be 2 pi. Now I'm going to consider the first and second quadrants and the values in them for when sine is equal to root 2 over 2. So, but now instead of pi over 4 and 3 pi over 4, right, I'm going to add 2 pi to those values. I'm going to add 2 pi to them because I'm going around the circle for the second time. So instead of pi over 4, right, and if you need a little refresher, remember that 2 pi is 8 pi over 4, right? So I'm going around 1 more fourth to 9 pi over 4. And here, remember, this is 3 pi, which is the same thing as 12 pi over 4, if you need that. This is 1 less fourth than that, so this is 11 pi over 4. That's how I remember it. But you can do 2 pi plus pi over 4 and 2 pi plus 3 pi over 4. You get the same thing. Okay, so we've got these values now. So what do I do with them? Well, I need to put them back into my original equation to solve for my other 2 values of theta. We need to put them back into, remember, our z equals 9 pi over 4, z equals 11 pi over 4 kind of equation. So remember, z equals 9 pi over 4, z equals 11 pi over 4. But remember, z was 2 theta. So 2 theta equals 9 pi over 4. Divide by 2. What happened there? 9 pi over 8. And I do the same thing over here. And so now what I have is I have these 2 other answers which go along with our graph, right, of sine of 2 theta, where this was pi, this was 2 pi, and here I hit pi over 8, 3 pi over 8, and now here are my other ones which I told you to look out for. 9 pi over 8 past pi, 11 pi over 8. So my answer, I've got my 4 answers now, 9 pi over 8, 11 pi over 8, which I just found on this page, and then pi over 8, 3 pi over 8. So that's why sine of 2 theta equals root 2 over 2 has 4 answers. Okay, so now we're going to do another kind of even trickier problem where the b is 3. Okay, so let's say we've got cosine of 3 theta equals root 3 over 2. I'm going to go back to the black writing here. So now we can kind of maybe take a guess at what might happen here. We know that when we had sine of 2 theta equaled something, we went around the unit circle, or we made 2 revolutions between 0 and 2 pi. And if we have 3 theta, maybe we can kind of guess, hypothesize that we might make 3 revolutions between 0 and 2 pi. Let's take a look. So we know that, for example, if we look at the period, 2 pi over b, which is 3. So the period is 2 pi over 3. So if I think about it, I'm going to just draw three revolutions and see where it gets me. So I know if I complete 1 revolution between 0 and 2 pi over 3, right, because that's the period. So if I then go another 2 pi over 3, I'd be at 4 pi over 3. If I do another one, then hey, look, I'm at 2 pi. So yeah, I do complete 3 revolutions between 0 and 3 pi. So what this is telling me is that now I'm going to have, before I had 4 answers for 2 theta, now I'm going to have another 2 answers, so now I'm actually going to have 6 answers. Okay, So let's take a look at what's going on here. We know that cosine of just, let's say, theta equals root 3 over 2, right? We know what theta would be here. Theta would be pi over 6 and 7 pi over 6 because, right, first and fourth, not 7 pi over 6, 11 pi over 6. So, because it's in the first and fourth quadrant. So then what I know is, remember how I said, okay, but now we've got cosine of 3 theta equals root 3 over 2. So let's let 3 theta equal W. So W then would equal pi over 6. W equals 11 pi over 6. But remember, 3 theta was W. So I divide both sides by 3, and I get theta equals pi over 18. And theta equals 11 pi over 18. Okay, so I've got my first two answers. So now, again, we're going to consider going around the unit circle 3 times. Right, that's what we're going to do. So if I have my unit circle, right, I know that I go around once and I get those first 2 values. When I go around again, remember, it's like now you're getting, what's 1 pi over 6 past 2 pi, right? That's 13 pi over 6, which is the same thing as pi over 6 plus 2 pi. And the same goes for the other value. So this would be, you can kind of think about it like 4 pi. We're going around again. And so what's 1 pi over 6 less than 4 pi, right? So that would be 23 pi over 6. And instead of just kind of thinking about it like that way, it is probably easier than to just add 2 pi. So I've got 13 pi over 6, and then I've got 13 pi over 6 plus 2 pi, 23 pi over 6, and then 23 pi over 6 plus 2 pi. So these values we know would be 25 pi over 6, and this one would be 35 pi over 6. Okay. So we've got, remember though, W equals 13 pi over 6. W equals 25 pi over 6. W equals 23 pi over 6. W equals 5 pi over 6. But what was W? And again, I would do it for all of them. Okay, so now I've got, I'm just going to shrink this a little bit. I've got these 4 answers, and then I've got my original 2. So in order, I've got now pi over 18, pi And there we go. And then you can carry that forward to 4 theta and 5 theta. I mean, it starts to be a lot of computations, but that's how it works.